Hello, my amazing math students. This is Mrs. A, and I love math. Tonight we're on lesson 77 of your Saxon Orange Book, and we're talking about consecutive odd and even integers. In the second half of this lesson, we're going to talk about fraction and decimal word problems. So, a lot of fun stuff tonight. So, here we go. Remember in the last lesson, we talked about consecutive integers, and we learned that we can model consecutive integers with n plus 1, and n plus 2. And consecutive integers are any numbers that go right after each other, like 5, 6, 7, or -3, -2, -1. So, they can be positive or negative because integers are positive or negative. But now we're talking about consecutive odds or evens, and the cool thing about this is odds and evens are modeled the same way. n plus 2, n plus 4, and we could keep on by adding 2 more each time because odds and evens both skip. Okay, so if I wanted to say 35, 37, 39. 35 would be the first of 3 odd numbers. So 35 would be n. If 35 were n, then 35 plus 2 would be the 37, and 35 plus 4 would be the 39. But what if my first number was even? What if my first number was 16 and I wanted to model even numbers instead of odd numbers? So my first number n would be 16. 16 plus 2 is 18, and 16 plus 4 is 20, and don't I have consecutive even numbers? So the fun thing to memorize about consecutive even and odds is that you model them exactly the same way. It's just with an even number, you start with n being an even number, and with an odd, you start with the n being an odd number. And you wind up with evens or odds depending on whether you start with evens or odds. Okay, so here's our first of 3 problems with even and odd integers. Find 3 consecutive even integers such that the sum of the first and the second equals the sum of the third and -10. So let's see how easy this is. Find 3, so that's going to be n plus 2, n plus 4. Because remember, with evens, I jump over 1 and I add up by 2's each time, such that the sum of the first and the second, so here's the first, there's the second, n plus, sum means plus, n plus 2 equals the sum of the third and -10. So the third is n plus 4 plus -10. Okay, so it's as easy as that. So n plus 2 is 2n plus 2 equals n plus 4 plus a -10. So that's going to n minus 6. So now I have a 2n and an n. If I subtract an n from both sides, now I'm going to come up here and write because I'm out of room. 2n, take away an n. So I'm going to take away an n, take away an n, and I'm going to get an n plus 2 equals a -6. So now I'm going to subtract a 2, subtract a 2, and I get n is -8. N is -8. Now, is that a good answer? Is it an even integer? It is. So we're going to say n is -8, which means n plus 2 would be 2 added to a -8, which would be a -6. And n plus 4 would be -8 plus 4, which would be a -4. So now let's go back and see if this is true for these numbers. So the sum of the first and the second would be -8 plus a -6 would be a -14 is equal to the sum of the third and -10. So -4 plus a -10 is a -14, and we get -14 is equal to -14, and I do believe that's true. Okay, so this is our second example. Find 3 consecutive odd integers such that the sum of the first and the third is 7 greater than the second decreased by 18. Okay, so again, I'm going to model with an n plus 2, and an n plus 4. 3 consecutive odd integers. So the only thing that's going to make this odd is that the first one will be odd. Therefore, the ones that follow it will be odd. Okay, so the first and the third added together. So that's going to be n plus 4, because that's the third. The sum of the first and the third is 7 greater than, so it's a plus 7 at the end. The second, which is n plus 2, decreased by 18. So this one decreased by 18 is a minus 18. Okay, so let's see if we can work this one out. N plus 4 is 2n plus 4 equals n plus 2. N plus 2 minus 18 would be n minus 16, plus a 7 would be n minus 9. Okay, so now I'm just going to check that. The 2 plus the 7 is 9. Take away the 18 is negative 9. So we got that right. So now I'm going to subtract an n, and get n plus 4 equals negative 9. Subtract a 4, subtract a 4. N is negative 13. Is that an odd integer? It is. So if n is negative 13, that means n plus 2 is negative 11, and n plus 4 is negative 9. And let's see if it works. So the sum of the first and the third, when I add these two together, I get negative 22 is equal to 7 greater than the second decreased by 18. So that's negative 11 minus 18, and then 7 more than that. So when I add a negative 18 and a negative 11, I get a negative 29. But then I add a 7 and I get a negative 22, and it works. I really love these problems. So there's the problem number 2. Okay, so here's the last one of this section, and then we'll go do section B. Find 4 consecutive odd integers such that the sum of the first and the fourth is 25 greater than the opposite of the third. All right, so here we go. Then we're going to have an n plus 2, an n plus 4, but we need 4 of them, so the last one would be n plus 6. The sum of the first and the fourth would be n plus 6 equals 25 greater, so plus 25 at the end of it all. Then the opposite of the third, so 1, 2, 3, the opposite of the third. Okay, so let's see. n plus 6 is 2n plus 6 equals negative, this is negative n minus 4 plus 25. So 2n plus 6 equals negative n plus 21. So now we're going to add an n and add an n to get all the n's on one side. 3n plus 6 equals 21. Minus 6, 3n equals 21 minus 6 is 15. Divide by 3, n is 5. So if n is 5, then we have 7, 9, 11. Let's see if it's true. The sum of the first and the fourth is 16, is 25 greater than the opposite of the third. The third is 9, and the opposite would be negative 9. Negative 9 plus 25 is 16. And it works. So that is the last example on this section. And now we're going to move to part B of this lesson, which is fraction and decimal word problems. Okay, so here we are with fraction and decimal word problems. And when we're doing any kind of a problem with math, of in a math problem means times, and is in a math problem means equals. Now, your Saxon book loves to have these little equations. And so basically what they're doing is this. So times and of are the same thing. And then equals is the same as the is. So basically they're doing the same thing, but they like f times of equals is, which if you like that, use it. It's fine. I learned how to do it by just plugging in a times every time I saw the word of, and it works too because it's the same as this. Now we're going to use the little diagrams, and when we were doing percentages, the whole, I call them egg problems, the whole egg meant 100%, but we know that 100% is the same thing as one whole. And so in our problems with fractions and decimals, our whole egg is going to represent one whole, or 1. Okay, so here we have our first example. Lopez used a 5-iron, but the ball covered only 4/5 of the required distance. If that was only 112 yards, what was the required distance? So, in this problem, we know that he actually shot the ball 112 yards, which was 4/5 of what he wanted to shoot the ball. So 4/5 of the required distance, you could use an R or a D for distance, 4/5 of the total distance he wanted to shoot the ball was equal to the 112, because 112 was the 4/5. So we could say 4/5 of the distance was equal to the 112. Okay, and then we want to get rid of the 4/5 because we're looking for that distance. So we get rid of the 4/5 by multiplying by the reciprocal on both sides. This cancels out, and we get distance is whatever 112 divided by 4 times 5 is. So 112 divided by 4, we know that 25 4s in 100, 3 more 4s in a 12, 25 plus 3 is 28, so 28 times 5. And 28 times 5, 5 times 8 is 40, carry the 4, 140. So the total distance was 140, okay? Now, what the Saxon book likes to do is it likes to use the equation here. They're using a fraction. So they would say fraction times of equals is. All right. So they're kind of giving you a hint to go look at the is word and put it on the other side. So here we said fraction was 4/5 of the distance. So where the of was, we put a times. Is 112. So where the is was, we put a equal sign. So it's the same thing as what they're doing here. They just like the little equation. And some people really, really like that equation, but it's just up to you. As long as you remember that every time you see the of, you're going to put a times. And every time you see the was or the is, you're going to put the equal sign. It's pretty easy. Okay, so now when we're using our little diagrams here, how would we use a diagram with this problem? We know that the entire thing was what we were looking for, the total distance. Okay, but we only had information about a part of the distance. So if we were going to draw a diagram, we would have had one that was the whole. So this was the whole distance. And then we would have had one that had the little cracked egg where we would have said this part here was 4/5 of the distance, okay, and the 4/5 of the distance was the 112. And then here would have to be the 1/4 of, 4/5, excuse me, the 1/5 of remaining distance, because 4/5 plus 1/5 is going to be the whole. So 1/5 is going to end up adding to it. So we could represent it, but this is really our equation right here. 4/5 times the distance equals 112. And then we found out that the whole was 140, and 1/5 of 140 is going to be what goes right here, and it should be equal to 28. So is 1/5 of 140 equal to 28? And yes, it is. All right, so here's the second example in this section. Maccabee guessed that the total was 30.24, but this was 7.2 times the total. What was the total? Okay, we don't know what the total is. We just know that this amount is 7.2 times the total. So they're representing this with what I call the peanut, right? The total, and then this one is more than the total because it's 7.2 times the total. But let's just see, what do they have for us? 30.24 is 7.2 times the total. And we're trying to find the total, which means we're trying to get the total all by itself. Can I not just divide by 7.2 on both sides? Divide by 7.2? Divide by 7.2? Don't I have the total by itself now? So 30.24 divided by 7.2. Okay, well that's going to be more than I can do in my head. And divide by 7.2. And I'm going to move my decimal here one time, and I move my decimal here one time. And I'm going to say 72 goes into, I'm going to say it's about 6 times. Okay, so because it's going to go, no, not about 6 times. It's going to go about 4 times. Excuse me, it's late at night. 4 times 2 is 8. 4 times 7 is 28. And then I'm going to subtract, and that's going to give me, that one is going to give me a 9 here. So 4 and a 1 and a 4, and 72 into 144 is 2. And my decimal's right there, so it's 4.2. And I think that's the right answer. And it is. Okay, so this is a little bit fuzzy here, but we're just dividing 30.24 by 7.2, and we get 4.2, and that is the answer. So there is the work for that one. Of course, you could always check it by taking 4.2 and multiplying it by 7.2 to see if you got 30.24, and you do. Here's the last example before we do our practice problems. 3/4 of the tickets had been sold, and there were 420 tickets left. How many tickets were printed? Well, if 3/4 had been sold, 3/4 from a whole leaves only 1/4 of the tickets left. But 1/4 of the tickets is 420. So 1/4 of the total tickets is 420. So multiply by 4 on this side, multiply by 4 on this side. Tickets equal 420 times 4, which is going to be 1,680. The total number of tickets was 1,680. That was pretty simple. Now, this is the diagram that they're showing. They're not really doing a lot with the diagram, but they are making this conclusion. They started with the 3/4 in the problem, but you really didn't want the 3/4. You wanted the 1/4 left over. So you really wanted to equate the 420 to the 1/4, and that's what they're showing you in the book. Now we'll do our practice problems. Okay, here is practice problem A. Find 3 consecutive even integers such that the sum of the first and the third equals the sum of the second and negative 14. So I want you to copy down the problem and think about, first of all, that our evens are going to be n plus 2 and n plus 4. And I want you to do it by yourself and then come back and see if you got it right. So press pause. All right, so hopefully you paused and you went and did it. So we have the sum of the first and the third. So the first and the third would be n plus 4 is equals the sum of the second. So the second is n plus 2 and negative 14. So n plus 4 is 2n plus 4, and n plus 2 plus a negative 14 is a negative 12. So we'll just put minus 12. All right, so subtract an n, we get n plus 4 equals negative 12. We're going to subtract a 4 from both sides. N is negative 16. Okay, it is even, isn't it? It's negative. So let's write down negative 16 and then add to negative 14 and then add negative 16 plus 4 is negative 12. And let's see if it meets the requirements. So the sum of the first and the third added together is negative 28 is equal to the sum of the second and negative 14. Negative 14 and negative 14 is also negative 28. So we have negative 28 equals negative 28. And we win. All right, so 2 more practice problems. Okay, again, this is your practice problem. Make sure you copy it down and go do it yourself. The golfer used a 6-iron, but the ball only traveled 5/6 of the distance. If the golfer hit the ball 180 yards, what was the required distance? So he only hit it 180 of the amount that he wanted to hit it, but that was 5/6 of the total distance. So we could set up a problem, 5/6 of the total distance, we'll just call that T or D. 5/6 of the total distance was 180 yards. Okay, so if we were going to split this with the diagram, we could say, here's my hole, and here is my 5/6, which was 180, and then my 1/6 would be what? Okay, so on this one, we're going to set the 5/6 equal to the 180. So 5/6 of a total distance is 180. To get to the total distance, we're going to multiply by 6 over 5. We're going to multiply by 6 over 5. That's going to cancel this out, and we have T equals. Now I have to do this math, okay? So 180 divided by 5 is going to be 36. Okay, so 36, because there's 2 5s in every 10 is what I'm thinking. Okay, so 36 times 6. So 36 times 6 is 18, 19, 20, 21, 216. So 216 was the total, okay? So 1/6 of the total would have been 36. And if I added the 36 plus the 180, I would have gotten 216, right? So it works. It works. And we have 1 problem left for this lesson. All right, so 7/8 of the tickets had been sold, and there were 560 tickets left. How many tickets were printed? So we have 7/8 of the total number of tickets had been sold. They're talking about how many are left. So if 7/8 have been sold, 1/8 of the tickets are left. And that equals 560. So we have to make sure that we compare like things with like things. So 1/8 of the tickets were not sold, which is 560. So now I'm going to multiply by 8 and multiply by 8 on this side. So now I have the total number of tickets is 8 times 0 is 0. 8 times 6 is 48. 44. So I have 4,480 tickets, and 1/8 of that is going to end up being divided by 8. Looks like it is right, because that divided by 8 is 5 with a 48, which is 6. Yep, that looks like it's right when I divide by 8. So the total number of tickets was 4,480. Now, if we took that 1/8 and then we took 7/8 of that, then we would know how many the 7/8 were. But we really didn't have to know that in this problem. We are done with lesson 77. This is Mrs. A. May God bless your day.